Imagine playing a game of football without a proper pair of boots. The right footwear absorbs shocks, provides adhesion in most conditions and perhaps most importantly provides grip when braking. The tyres on a vehicle provide a very similar function, although they are of course safety critical. That's why when it comes to the MOT test, it's important to tread carefully. Tyres look pretty simple on the surface, but as they say, the devil is in the detail. And as ever, we've got a man from Vehicle Inspectorate to illuminate it, Tom Callahan. Tom, how are you doing?
I'm fine, Claire.
Good.
Hi.
Now, testing tyres. Do you need any special equipment for that?
Yes, you do. You need the Vehicle Inspectorate approved tyre tread depth gauge. This particular one is marked up with markings of tyre tread depths, and it includes 1 millimetre and 1.6 millimetre. And of course, you need the inspection manual.
So, Tom, can you take me through the route that you'd use to test the tyres?
Yes, Claire. Normally, we'd start at the front of the vehicle, and we'd go around the vehicle in a continuous routine, checking each tyre in turn. But for the purpose of this exercise, we're going to concentrate on this one tyre. And we've raised the vehicle up. It wouldn't necessarily be in this position.
Now, obviously, we can see lots of different markings on the tyre here. What do they all mean?
They are well marked. There's the tyre size, there's ply ratings and load index ratings, which identify the load carrying capacity of a tyre. There's speed ratings, which identify the maximum speed at which a tyre can be used. Load ratings and speed ratings don't apply to a tyre such as this, but they do apply to Class VII vehicles.
Now, you mentioned speed rating. What if there is a speed rating on a tyre, and obviously the vehicle to which it's fitted can go a lot quicker than that?
All we ever consider in this country is the legal speed requirement, which is 70 miles an hour. So, irrespective of the marking, provided the tyre was capable of 70 miles an hour, that would be acceptable. Wouldn't apply to a car of this type, but obviously if I were dealing with a Class VII vehicle and the tyre marking indicated that it couldn't run at 70 miles an hour, it could run at a lower speed, it would fail.
Now, we can see the size markings on the outside of the tyre there. What do they all mean?
Right, in this particular tyre, Claire, there's a 185, which is a measurement in millimetres, and that relates to the cross-sectional width of the tyre. There's also a 65, which is a percentage, and that relates to the aspect ratio. And there's a 14, which is inches, and relates to the size of the wheel.
Now, you mentioned aspect ratio. What's that?
The aspect ratio, as I said, is a percentage, and it's the relationship of the height of the tyre wall to the cross-sectional width of the tyre. In other words, this tyre wall is 65% of the cross-sectional width of the tyre. Now, some tyres don't have that marking at all. They would just say, in this case, 185/14. They actually have a standard 82% aspect ratio. So if I had a tyre that was marked 185/14 and a tyre that was marked 185/80/14, they would be considered as the same size tyre.
Now, you see an arrow on some tyres. Does that just mean the direction to which the tyre's fitted?
Yes, some tyres are marked in this way, and they will be marked with an arrow and the word rotation, and obviously the arrow has to indicate the right direction. If it were indicating the wrong direction, it would fail, provided that there was the arrow and the word rotation. If it was simply an arrow and it were facing the wrong direction, we would pass and advise.
And sometimes you see something like outer or outside on a tyre, don't you?
Yes, you do. And that indicates that that wall of the tyre must be to the outside of the vehicle, such as in asymmetric tyres.
Now, different types of tyres. What's the difference, say, between cross-ply and radial?
The difference between cross-ply and radial is basically the design structure of the tyre, the way that the plies are woven in.
Now, how can you tell just by looking at a tyre whether it's a radial tyre or a cross-ply?
Well, in the case of this particular tyre, within the tyre size it has an R, which indicates that this tyre is a radial. Some of them have the word radial written on them. The cross-ply would not have this information.
Are there any other ways that you can tell?
In the case of the radial, it's the way the size is laid out. Normally, radials would be marked in this way with millimetres for the cross-sectional width against inches for the wheel size. The cross-ply would have the cross-sectional width indicated in inches, for example, 5.60 inches, and the wheel size in inches, 5.60/14. That would be a cross-ply tyre. Tyre sizes marked in inches can also be found on some commercial radials. Class 4s, such as large motorhomes, tend to use these.
What about mixing the two types of tyres up? Is that something you can do?
Firstly, you can never mix the types across an axle, as you can never mix sizes across an axle. But you can mix them around the vehicle in certain ways. If I explain it to you this way, if I had a vehicle that had only 4 wheels, 1 wheel on each corner, then the cross plies must be fitted to the front axle and the radials must be fitted to the rear axle. Simple rule is R for radial, R for rear. But in the case of vehicles with twin tyres on the back, that rule does not apply.
On a twin-wheeled vehicle, what would happen, say, if one of the wheels didn't touch the ground?
Well, this is quite possible. If, for example, one of the tyres was a new tyre and the other tyre was well worn, it's quite feasible that the worn tyre wouldn't necessarily touch the ground. That's not a reason to fail. That would be a pass, provided they're the same size tyre and type.
Tom, do all the tyres have to be the same size?
No, they don't, Claire. They have to be the same size across an axle, but for example, you can have large tyres on the rear axle than you have on the front axle. The marking sizes on tyres, some tyres will have 2 sizes marked on the tyre wall. For example, you could have a 185/75/14 indicated on the tyre wall, and on that same tyre, you could have a 185/80/14, so it indicates 2 tyre sizes. On the tyre on the other side, you could have a 185/80/14. Now that would be acceptable because both tyres contain the same information. Another variation on that is you could have a 175/14 on one side and a 175/80/14 on the other side. And because a standard tyre, 175/14, is 82%, then it is considered as the same size as the 80, and that would be acceptable.
Now the spare wheel, is that part of the test?
That's not part of the test, but if a tester should happen to notice that the spare wheel or tyre were defective, it would be best practice to let the presenter know.
Now what if the vehicle's got a space saver wheel on it? What happens there?
Now, space saver wheels, if they were fitted as a road wheel at the time of test, then it would fail.
Tyre pressures, is that something they check in the test?
There's no requirement for any tester to check tyre pressures, but if you can see that the tyre is underinflated, the tester would sensibly need to consider whether they can carry out an effective headlamp aim test or if it would be safe and sensible to carry out a roller brake test.
When you're looking at the underside of the vehicle, is that when you would inspect the tyres?
Yes, when the vehicle is on the ramp and bearing the weight of the vehicle, it's a good opportunity on the inner tyre wall to look to see if there's any bulges, particularly around the edge of the tread, that would be exaggerated because the weight is on the tyre.
Now obviously the tread of the tyre is vital. When do you check the condition of that?
Well, the best time, Claire, would be when the wheel is raised so we can see the entire outer circumference of the tread. And I'm going to jack this vehicle up just so we can do that. Once again, Claire, we're going to restrict ourselves to inspection of this tyre. It's much easier that way. Of course, every other tyre on the vehicle will get this type of inspection. It's a point to remember for testers here. If they're dealing with a vehicle that has ABS braking system, they must make sure the ignition is switched off before they ever rotate a wheel. We're going to consider the breadth of tread, which is that part of the tread which makes contact with the road under normal driving conditions. And we're going to check that around the entire outer circumference of the tread area. Now, for most vehicles, it will be a tread depth measurement of 1.6 millimetre, measured on the centre 3/4 of the tread area around the entire outer circumference. The remaining 1/8 either side can be devoid of tread, that is to say, bald. But it's considered highly unlikely that a tyre could have this area bald and then suddenly come into the 3/4 and meet the 1.6 millimetre tread depth minimum. But if the tyre did do that, it would be a pass.
Now we can see the actual tread depth indicator on this particular tyre here. Is that something that testers should rely on?
No, it isn't. They must use the tyre tread depth gauge because that tread wear indicator won't necessarily be set at 1.6 mil. And they simply place the gauge in like so and press it down till it touches the tyre, and then they can read off whatever the depth of the tread is. The tread wear indicator is not part of the tread pattern. And if you were to imagine that this tyre were worn right down so that it was flush with the tread wear indicator, it would appear as a small bald patch, and testers must disregard that.
And 1.6 millimetres is a figure we're all familiar with. Does that apply to all vehicles?
No, it's not clear. The majority of tyres will be 1.6 millimetre, but any vehicle first used before the 3rd of January 1933 only requires to have 1 millimetre tread, as does any passenger vehicle with at least 8 passenger seats, excluding the driver. That only requires 1 millimetre of tread, but there's a different criteria for measuring the tread. Can I explain that to you? I mentioned how we measured the centre 3/4 on the 1.6. For the 1 millimetre, it is any 3/4 across the tread. Must be a continuous band of not less than 1 millimetre. Any remaining tread pattern must be a visible pattern, but doesn't have to be 1 millimetre.
Now, some tyres actually have areas where there's no tread pattern, don't they?
Some vehicles, by the original design of the tread, there is no tread pattern on the outer edge. And so that would not be considered as original tread, and it will not be a reason to fail it.
What about recuts, Tom?
A tyre on a vehicle such as this, if it had a recut, it would fail. However, there are some vehicles that are entitled to have recut tyres. For example, any goods vehicle that has an unladen weight at least 2540 kilos with a wheel size not less than 405 millimetres or 16 inches. A passenger carrying vehicle with at least 8 passenger seats, excluding the driver, with an unladen weight over 2540 kilos, or any vehicle with an unladen weight over 3050 kilos.
What other defects would you look for in the tyre?
Apart from the tread depth, okay, in the tread area you would be looking for cuts, exposed cord, you'd be looking for lumps, bulges, tears, separation of the structure, the tread lifting, those kind of defects. And in the wall area you would be looking for the same things. However, on radial tyres, such as this type, some of the tyres have effects left on them from the manufacturing process. For example, there could be, say, a ridge here. It's like a finger and it's quite a hard ridge. And you'd have the same effect on the other side of the tyre, identical. That's part of the processing. Or sometimes it's like an undulation, it's like a little valley. It's like a finger length. And the same thing on the other side. And they are part of the manufacturing process. They're not a defect in the tyre. In the case of cuts, they need to be of a certain dimension. They must be at least 25 millimetre or 10% of section width, whichever is the greater measurement. And that cut must be deep enough to reach the plier cord. So as you look at the cut, you would not be able to see the plier cord. So you would need to investigate. Very, very carefully open the cut. And if it were deep enough to reach the plier cord and met those dimensions that I've mentioned, then it would fail. But then, of course, you have the other reason for failure. Any of its plier cord exposed, so you're not touching the tyre, you're just looking at the tyre and you see cord exposed, the dimension's not relevant. Doesn't matter how small its exposed cord, it fails.
Now, will the vehicle fail its MOT test if any part of the tyre's actually perished?
By perished, I take it you mean the fine cracking all around the wall of the tyre. No, it wouldn't necessarily fail because it was perished, but if the perishing had developed to the stage where it now met the fail criteria for cuts or exposed cord, then it would fail for those reasons.
Do you test the valve?
Yes, you do check the valve, and you check the condition of the valve to see if it is damaged or misaligned, such that you consider it's likely it would cause sudden deflation of the tyre.
Now, we mentioned before about how the tyre's fitted. That's obviously important, isn't it?
Yes, it is. The tyre must be fitted correctly to the wheel, and we would be looking to see if there are any obvious gaps between the bead of the tyre and the wheel rim, and if there were, it would fail.
What if parts of the tyre are obscured, say, by the bodywork?
With the vehicle jacked up, which is the best time to check the tyre, a tester can expect to see the whole of the tyre and be able to examine it all.
On a twin-wheeled vehicle, how do you cope with access to the inner wheel?
When the vehicle's raised on the jack, a tester would successfully be able to see the inside of the inner tyre wall from underneath the vehicle. The tester would also be able to look up between the wheels, and as they rotate the wheel very carefully, they could expect to see the inner walls of both tyres.
Does it make any difference if the two tyres are actually touching?
If the tyre inner walls were making contact because the tyres were incorrectly fitted or they were underinflated, then that would be a reason to fail. But it is possible that perfectly well-fitted tyres and properly inflated tyres, the inner walls can make contact when the vehicle is loaded, and if that were the case, it would not be a fail.
Should the tester be looking to see if the tyres are rubbing up against any part of the vehicle?
He would check for fouling of the tyre when the vehicle is resting on free-moving turn plates and it's moved through lock to lock to see whether the tyre were found in the bodywork, steering or suspension. There are certain vehicles that have a different design of lock stop in that they have soft metal pads within the inner part of the wing, and the tyre will rub against that soft metal pad when it's on full lock. It's part of its design feature. The most common example of this is the Morgan. Now, that would not fail unless, of course, the pads were in such a condition that they would damage the tyre.
Now, Tom, you mentioned Class 7s before.
Yes, I did, Claire. Let's go and have a look at one.
Tom, I believe there are some specific issues relating to Class 7 vehicles, aren't there?
Yes, there are. The tester needs to identify the carrying capacity of the tyre, and also they need to identify the speed rating symbols.
So how would they find that out?
Well, they will read the information off the tyre. For example, here we have the tyre size, and we have, for example, the speed rating symbol. Now, on Class 3 and 4, there's no requirement to identify the speed rating symbol. But on Class 7, there's a requirement to use the symbol if it's available. Now, this tyre has an N-marked symbol. The tester's manual tells us that symbols A, B, C, D, E, F, G, J, or K are unacceptable. Therefore, this symbol is acceptable. As far as the carrying capacity is concerned, the tester would use the tyre size, the ply rating, or the load index reference.
So how would you find out what the weight carrying capacity of a vehicle like this was then?
That information would be available on the manufacturer's plate, and the manufacturer's plate would tell us the maximum permitted laden weight for each axle and the maximum permitted laden weight for the vehicle as a whole. The tester would take this information here, and by using a chart in the tester's manual, he would be able to identify the carrying capacity of the axle.
So how does the tester use this chart that's in the manual then?
Now, I've taken the details from the manufacturer's plate. On this particular vehicle, the tyre size is 185/14. The ply rating is 8 ply, and the load index reference is 102/100. On the first axle, which has single wheels, it has a maximum carrying capacity of 1,700 kilos. The manufacturer's plate lists 1,330 kilos, so this is more than adequate. On the second axle, with twin wheels, the maximum carrying capacity of these tyres is 3,200 kilos. The manufacturer's plate tells us that it carries 2,600 kilos maximum, so this is more than adequate.
So what about the wheel then?
Yes, we can go and look at some road wheels now. Claire, a tester would be examining this wheel to see if it were badly damaged, particularly around the rim of the wheel, and if it were, it would fail. But he would need to consider whether the tyre was likely to suddenly deflate or whether it affected the control of the vehicle. And if he considered it did not, then he could pass an advice. He would also examine the wheel to see if it were cracked or distorted, and if it were, it would fail.
So Tom, what about the security of the wheel?
The tester would examine to see if the wheel was secured to the hub satisfactorily. He could assess this when he's doing the suspension checks. He could feel for looseness of the wheel. If the wheel nuts were exposed, then he could check the wheel nuts to see if they were secure. Any one wheel nut loose or missing would be a reason to fail.
Does the tester actually have to remove any wheel trims or hubcaps?
No, there's no requirement for them to remove the hubcaps or wheel trims. The vehicle is to be tested as presented.
So Tom, is there anything else we need to know?
Only if a tester is unsure. There's obviously the information and inspection manual. They can contact their local vehicle examiner he'll be prepared to answer any questions they have.
Well, Tom, you've been brilliant. Thank you very much indeed.
Thank you very much. It's been my pleasure.
The Vehicle Inspectorate website can be found on www.via.gov.uk or call 0845 600 5977.